Kuliah, BSI Aja.
Good afternoon, ladies and gentlemen. A warm welcome to you all to the webinar Studium Generale Universitas Bsi Bersama Informatika on Monday, September 13th, 2021, live by Zoom, with the theme Information Security and Parallel Processing Correlated with the Artificial Intelligence. First of all, let us say thanks to God the Almighty, who has been given us guidance, happiness, healthy, and mercy, so we can attend and participate in this event without any obstacles. Before we start our agenda today, please allow me, Jimmy, as a MC, to greet and welcome to the Honorable Rector of Universitas Bsi Bersama Informatika, Dr. Muhammad Waidi, MM, MCom, MPD. The Honorable Keynote Speaker of the webinar Studium Generale Universitas Bsi Bersama Informatika, Professor Shi-Jinn Horng from National Taiwan University of Science and Technology. The Honorable Vice Rectors, Head of Bureaus, Deans, Head of Study Programs, Lectures, Staffs, and all invited participants. This webinar is organized by Universitas Bsi Bersama Informatika and the co-host Association of Higher Education in Informatics and Computing, Aptikom, Dki Jakarta, Provinsi. Ladies and gentlemen, allow me to read the rundown of this webinar. First, opening by MC. Second, Sing Indonesia Raya. Third, opening speech by the Rector of Universitas Bsi Bersama Informatika. Fourth, presentation webinar Studium Generale by the keynote speaker. 5, question and answer session. 6, conferral of placards symbolically by Rector. 7, documentation. 8, questionnaire link, and the 9, closing. Ladies and gentlemen, may we invite all the participants to have in good position and sing national anthem Indonesia Raya. Ladies and gentlemen, for the opening and welcoming speech, may we invite Bapak Dr. Muhammad Waidi, MM, MCom, MPD, as Director of Universitas Bsi Bersama Informatika, to say a few words to us. To Dr. Muhammad Waidi, MM, MCom, MPD, please Time is yours.
Okay. Thank you, Mr. Jimmy. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, and best wishes for all of us. The Honorable Founder of BSI Foundation, Mr. Herman Pratikto, the Honorable Head of BSI Foundation, Mr. Efriadi and his staff, respectable keynote speaker, Mr. Professor Shi-Jinn Horng from National Taiwan University of Science and Technology. Thank you for your time, Prof. Head of Indonesian Association of Higher Education in Informatics and Computing, Aptikom, Dki Jakarta Provinsi, and then of Faculty of Engineering and Informatics, Universitas Bsi Bersama Informatika, Mr. Didi Rosadi, MCom, the Honorable Vice Rector Academic Affairs, Universitas Bsi Bersama Informatika, Mrs. Dia Puspitasari, and all the invite who attends the Studium Generale, Faculty of Engineering and Informatics, Universitas Bsi Bersama Informatika. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon and best wishes for all of us. First of all, let us praise the presence of Allah Subhanahu wa Ta'ala, the most gracious and merciful, because with His permission today, we can gather together to participate in the Studium Generale event with the topic Information Security and Parallel Processing correlates with Artificial Intelligence. This event are collaborated Faculty of Engineering and Informatics, Universitas Bsi Bersama Informatika, and Indonesian Association of Higher Education in Informatics and Computing, Aptikom, Dki Jakarta Provinsi. And the development of computer technology is very interesting, especially in the issue of information security. Many users worry that their personal data stored and on the computer will be leaked or used illegally by irresponsible parties. The emergence of artificial intelligence technology can be effectively solve information security problem. So it's need to be studied more its application. Therefore, this webinar will answer all the matters relating to information security and artificial intelligence according to the times that are needed nowadays. Finally, welcome to the Studium Generale webinar to audience. Hopefully, the material that will be presented by the keynote speakers can be provide a lot of new knowledge and can be useful for webinar participants, especially for Universitas Bsi Bersama Informatika. And also thanks to Entry Studium Generale Webinar Committee and Marketing Communication Team Universitas BSI for holding this webinar event. Enjoy that event and thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you, Mr. Jimmy.
Thank you, Bapak Dr. Muhammad Waidi, MM, MCom, MPD, for the opening and welcoming speech. Ladies and gentlemen, before we start to begin to the honorable speaker, allow me to hand over this event to our moderator. He is head of English department, and he is head of English literature of Universitas Bsi Bersama Informatika. He is also English lecturer. He is progressing in accomplishing his doctoral course. Without further ado, ladies and gentlemen, please welcome the moderator, Mr. Agus Priadi, MPD. Mr. Agus, time is yours.
All right. Thank you very much, Mr. Jimmy, our adorable MC for today's webinar. I mean, for your prayer. Thank you, who allows me to continue this program with the discussion session. All right, ladies and gentlemen, the honorable attendees, I hope you are still excited and eager to join this webinar with the theme, Information Security and Parallel Processing Correlated with the Artificial Intelligence. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, dear participants. Thank you for your kind attention to attend this webinar. First of all, I would like to convey my warm welcome and thank you to respectable Bapak Dr. Muhammad Wahyudi MM.Com MPD as Director of Universitas Bina Sarana Informatika and all rectorate staffs. The Honorable Ibu Diah Puspitasari M.Com as the Vice Rector 1 of Universitas Bina Sarana Informatika, the Honorable Bapak Suharyanto M.Com as the Vice Rector 2 of Universitas Bina Sarana Informatika, the Honorable Bapak Dr. Didi Rosiadi M.Com as the General Chair of Indonesian Association of Higher Education in Informatics and Computing, or Aptikom, Province of Dki Jakarta, Honorable Head of Bureaus, Deans, Head of Study Programs of Universitas Bina Sarana Informatika, the Honorable Professor Shi-Jinn Horng from National Taiwan University of Science and Technology as the speaker of this webinar, and of course, the distinguished participants of the webinar. Thank you for your kind attendance. The webinar is organized and collaborated with Universitas Bina Sarana Informatika and Aptikom Province of Dki Jakarta. Before we begin the webinar, let me introduce myself. As the MC already mentioned before, my name is Agus Priyadi. I feel very blessed to have this opportunity to be the moderator for this discussion session. Dear attendees, the purpose of this webinar is really interesting. To those master degrees or graduates who would like to continue their study into PhD program, will be mentored by the professors, and they are able to gain scholarships or grants to universities all over the world by joining the world-class professor, one of the Kemdikbud programs. And dear participants, we are very fortunate and grateful to invite the keynote speaker today because we are going to see and to look and find out more detail about his explanations to broaden people's exposure and deep insight about artificial intelligence. But before we start, I would like to announce this request dealing with your with this collaboration. Please kindly mute the audio and please utilize the chat feature or raise your hand when we come to the question and answer session. And please kindly provide as many as possible questions regarding to the issues. Then please follow the format name _ institution _ questions. Then the certificate will be delivered to you by email. So please make sure that you fill the attendance link correctly. All right, ladies and gentlemen, I'm going to talk a bit more about information security, correlated with artificial intelligence. Cybersecurity nowadays in the digital era is a concern of various groups around the world because the more sophisticated the technology, the more sophisticated the tactics used by cyber criminals in carrying out malicious actions. Is that right? Cybersecurity is the activity of preventing and securing telematics resources so that crime does not occur in the cyber world. Given that there is no standard definition of cybersecurity, you can say that cybersecurity is an attempt to resist attacks in cyberspace. Okay, so what is the role of artificial intelligence in cybersecurity or information security? More or less about information security correlated with artificial intelligence, and I hope that I'm not wrong to tell us about that, but later on, for more details and complete, Professor Horng will explain about this. Professor Horng, this plenary lecture lasts for about 1 hour, 20 minutes. Before the speech, let us visualize his profile video. Shi-Jinn Horng, also known as Shi-Jinn Horng, received the BS degree in Electronics Engineering from National Taiwan Institute of Technology, Taipei, the MS degree in Information Engineering from National Central University, Taiwan, and the PhD degree in Computer Science from National Tsinghua University, Taiwan in 1980, 1984, and 1989, respectively. He was the Dean of the College of Electrical Engineering and Computer Science, National United University, Taiwan. Currently, he is a chair professor in the Department of Computer Science and Information Engineering, NTUST. He was a visiting professor at Tokyo Institute of Technology in 2008, Georgia State University in 2007, University of Dayton, Ohio in National Mongolia University in 2004, and Southwest Chiao Tung University in 2004. He also worked as a PMTS at AT&T Bell Laboratories from 1990 to 1991. His research interests include deep learning, biometric recognition, multimedia, image processing, and information security. He has published more than 300 research papers and received many awards, especially the Distinguished Research Award between 2004 and 2006 from the National Science Council in Taiwan. Let us welcome Professor Shi-Jinn Horng. Please, the screen is yours. Do you laugh, Prof? Why?
So, can you hear me?
Yes, clear,
Yeah.
Prof. It's clear. Do you like
Okay.
the video?
Yeah, sure.
Okay.
So, can I share the screen now?
Yes, please. Yes, Prof.
Okay. So now, can you see this screen now?
Not yet, Prof. It's still going on. Yes, already. Now it's clear.
Okay.
Yeah.
Okay, that's wonderful. Okay, I just saw the introduction, the video about me. I'm so wondering how can you get so many information from me? It's not easy, you know.
Yes, Prof. It's secret.
Yeah. So I'm so thank you for you. Okay. Anyway, now I will present my talk. Okay. So today, you know, the talk is about the information security and parallel processing correlated with the artificial intelligence. Okay. So now I move here to this one. Okay. Oh. Okay. Okay. So can I just to move the okay. Okay. Today the outline is I just will follow this outline here. First, I will give you some introduction about the security, and then I will give two papers. One paper is to discuss how to detect ransomware using SVM. And the second paper is a general paper about how to detect the malware using the convolution neural network. That's very popular. We are doing deep learning. And finally, I will give you some of the conclusions. So first of all, we will go to the introduction. We say that for the information security, it can be categorized into two parts. One is the data security. The other is the network security. As you know, suppose someone want to protect his data or her data, he or she must use some of the we say the key, like a public key or secret key, to encrypt data, and then when he send the data to somebody, they can use the same key to the key to decrypt the data. So that's we say the for the data security problem. Okay, and also you can use the watermark technique to protect some documents or images or any other things. But we say this one also we say belong to the data security. The other one is the network security. Network security means, you know, when someone can use some other ways without any permission, but can intrude the your computer or somebody computer, they can use some like the malware, like the Trojan, ransomware, virus, and etc. And in today, my talk is about the network security. I am not talking about data security. Okay, so today we just focusing on the network security. So after I give you the introduction about the information security, I will go to the first paper. I just use the support vector machine to do some detection about ransomware. I know ransomware is very serious, you know, last year, and there are so many people they get infected by ransomware and pay so much money to the adversaries. So this paper is published in 2018 in ICPP. ICPP is very famous and a very important conference. And this paper is made by the Japanese. Okay, but anyway, we just follow the idea. I will show you how can they use the support vector machine to detect the ransomware. Okay. What's up? Okay. So the paper, you know, the first of all, you know, we just we give you that the why the ransomware is so serious. You know, in 2015, the total loss about the ransomware damage is about 24 millions. Okay, that's the 2015. But now, you know, in the 2016, in January and March, it's about only 3 months. The total loss is reached 209 millions. So that means, you know, it's about 10 times. Okay, and now go to the 2017, it increased to 1 billion. You know, so many losses. You know, so that's why, you know, somebody very serious about the ransomware, how to detect it. And as you know, why the ransomware is so serious? Because what? Because, you know, suppose, you know, victim they get the infected by the ransomware, and the adversaries will ask you to pay money, and the victim suppose he understand, okay, suppose the money is not so much, and the file is so important. So, you know, in that case, you will pay the money. But, you know, I got a ransomware before, but, you know, I did not pay money. I just turn on my computers, and then I just to reinstall my operating system. So I did not pay any money to the ransomware. Anyway, okay. So in this paper, you know, how can the worst try to get to detect the ransomware? First of all, he just tried to find some way to convert the API codes from the localhost to a vector. And in the second way, you know, I just want to use some of the normalization to do some of the standardized vector representation of the original model. And then based on this the data, the authors just use this data to do some training using the SVM, because SVM is very good way to do the classification. So in that case, SVM also very fast. So And also, in this paper, the words just use the Kaku sandbox. The Kaku sandbox is a virtual machine. Because of what? Because the words want to use the Kaku sandbox to get some of the dynamic behaviors of the program. The program, as you know, is a good way or bad way. Probably is a bad way is a virtual way. Okay, here. Okay. So because suppose you want to get the dynamic behavior, you cannot directly run the program in the Windows system. Suppose this program is a virus or is ransomware. If you run it directly in your Windows system, then your computer will be infected. That's so serious. So usually, suppose if you want to get some of the dynamic behavior, we must use the sandbox like the Kaku. Okay, here I show you is the Kaku. Okay, Kaku is one of the sandbox that you can run any program in the Kaku. Okay, so in the case, that means the ransomware or the goodware are executed. Okay, and then the way is we just want to get some of the vector data. So first of all, we want to see what's going on, why the adversary can just to data the victim like you or me to be infected. Okay, the idea is here. The ransomware, the adversary, he deploys a key server probably in the server, and he just generates a pair of public and private keys and store this data in the console in the command server. And this server is I would say is controlled by the adversaries. So when somebody get infected from this ransomware, and the victim, I would say the computers, the program running in the victims, will send a command to the CNC server here to get what? To get a public key. And this public key will just download to the victim's computers. And then suddenly, I think a moment, 1 second, all the files, including POC file, Word file, PDF file, any file, okay, will be encrypted by this public key. And then the CNC server will send a message to the victim screen, say, okay, now all the files in your computer is encrypted by the public key. Suppose if you want to decrypt your key, decrypt your files, you must send the money. Okay, that's the important thing. Send the money to the adversaries, then they will give you the private key. Okay, and usually the adversaries will ask you to send the money by Bitcoin. As you know, Bitcoin is very, very popular now. Okay, anyway, and also why they use this Bitcoin? Because when you use the money through Bitcoin, like in Taiwan, if I want to wire some money from Taiwan to Indonesia, all the money will be checked by the government. But suppose if you wire money by the Bitcoin, nobody knows, So that's why adversary, they will use this way to get to ask the victim to say, okay, you must send money, send Bitcoin to me, then I will give you the private key to decrypt all the encrypted files. That's the basic idea for the ransomware. So now the version, the method he proposed, just use a way this here. So first of all, the was okay. Now I just convert. Okay, I just convert all the programs. Either it's a ransomware or it's a goodware to a set of vector data, and then the words use SVM machines to learn this big data. That means what? He want to train this SVM machine to data the SVM machine to understand which ware or which software is a goodware, which program is badware, or we can say the ransomware. And then finally, after the SVM is trained the badware, then the SVM can be used to detect some of the incoming program, like either we say the goodware or badware. Okay, that's use the SVM to do the detection. Okay. So now I will give you some of the notation here. I think notation you can see here, you will be headache. Okay, I think so. I don't want to go any details about the notation here. I just will say, okay, I said the capital A. Capital A means what? Means, you know, suppose there's a program and the API codes used in this program, we use the A. Okay, that's the simple sense. And the small AI here means, you know, the one of the API codes in the A, okay? Right. And this is notation is. It means what? It means the Qgram or the API codes. I think, you know, I can understand all these things. I will just give you an example to show what's going on. It's very, that could be an easy way, okay? So now, the thing is that we say originally I tell you that I just want to transform the original program to a vector, and this vector we denote this one as a phi of x. X means the log files or the program. Log file means what? You run this program, and this program could be goodware or could be ransomware. So you must run this program in the same box. That's very important. Okay, anyway. So suppose if you can run this program and then you can get the log files for this program, then we can convert this log file into a file of X vector here. Then how to convert it? It's easy. Okay, let me give you an example to show what's going on. Okay, first of all, I say suppose, you know, your program has two API codes, A and B. Okay, API code A and B. And then the program, just when you run in this program, and then you can see the log files of this program is, first of all, it's a code API A, and then code B, and then code A again, and then code B again. That means, you know, this program, when this program is running, either first call A, and then call B, and then call A again, and then call B again. So this is the behavior of this program. So I just show here, okay? Behavior of a program. That is A, B, A, B. Call A, then call B, then call A again, then call B again. Now, what we want to do is because, you know, we want to use a two frame. Two frame means what? We want to see what's going on. Suppose, you know, we just to data the original the API. We have two API calls here, A and B. So we just do the permutation of the API, because I know this program consists of two APIs, A and B. So I do some of the permutation about this API. So I know I have the A and the B. So now I have a whole permutation, A, B, BA, and the BB. So from this API code to API codes, I can get whole permutations. And the permutation is what? I just choose two elements. So these two elements means 2 gram. These two elements 2 gram, okay? So now this is the permutation of all the API. Okay, now we want to see what's going on or this program. The log file or this program is ABAB. That means what? We then scan the behavior of this program from left to right with a window size of 2. Okay, so from here, AB, the window size is 2, right? So we all get AB. Then from this AB, we just check where's the AB or A, B, B, A, B, or AB is here. So we put 1 in this position. Okay, in the corresponding position is 1 here. And then out of this one, we just shift these windows to right 1 position. So AB go to BA. Okay, AB go to BA. So in this case, we get another 2 grams BA. We use the BA to check the permutation again. AB is here. So we put 1 here. Okay. And then out of this one, we just shift this window size to write one position. So we get the AB, okay, AB. So AB, we check again, AB, all here. But originally we have one here. So now we get another one is the same sense. So that means one and one is also one, okay? So now the behavior of program is here. You know, this program probably is a good way, right? Or this could be a ransomware. But anyway, the program just, as you know, that he just want all call A and call B and call A and call B, blah, blah. Okay, this is the behavior program. But now, we know this is the behavior program. What do we want to do? We just want to convert the behavior of this program to a vector. So that means, you know, AB is converted to the 0, 1, 1, 0, this vector. So this vector is used to represent the behavior of program. For example, probably you have A, B, A, B, A, B, B, A, B, B, right? So you have a long behavior program, but you convert this vector, you probably can only see 4 items here, okay? So that's I say. You have behavior program, we convert this one to the vector. So even your program is very long, right? Even very long, but you know your vector just only 4 elements. Okay, anyway, that's the idea here. Okay, so the next thing is, you know, suppose I have 2 programs, and on the program 1, the log file is put here, A, blah, blah, BA, and the program 2, I have the log file is A. Okay, we want to know what's going on. Suppose if we use the idea we just I just give you previously, we want to convert, okay, this log file into a vector, and we want to convert the second log files into another vector. Okay, let me see what's going on. Okay, as you can see here, right? This is the first program, the log files A. Then we just follow the idea I just did previously. We scan this behavior from left to right, and with a window size of 2, so we can get AA, right? Also AA, we put 1. Then shift to the right position, AA, we get 1 again, and then shift to the right position, AA, we get another 1 again, and AA, right? Always is put 1 here. And then we get an AB, right? So AB is put 1. And then we get a BA, so BA put 1. But we don't have a BB, so B is 0. Okay, anyway. Now the behavior of this program, the log file, we convert this log file into a vector. I just show you here, right? And another one is the second program. We say the log file, the second point is here. A. So you can see what's going on in this vector. You first of all, AB, you can see AB, you put 1, then BA, you put 1, and then AA, A is 1, and then AB is 1, BA is 1, blah, 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 AA is 1, right? So after you scan the behavior or the log file, then you can see you convert this log file into a vector like this way. But now, the first program, you get this vector 1110. The second program, you get another vector 1110. Wow. So the different program 1 and the program 2, they are different, but their vector is the same. Suppose program is goodware, like Windows, right? Program 2 is a badware, is a ransomware. But you know, out mapping, they map it to the same vector. You know, that's a disaster. That means what? You cannot use this vector to identify is it a goodware or is it a badware. So understand the idea here? So now, so because of what, you know, in this case, you know, the behavior of a goodware and the behavior of badware all are mapping to the same vector. That's a disaster. So the author said, no, we can do that. So we must have a way to identify the vector here. Suppose, the good where can get a vector here, and the bad where get another vector. And these two vectors, they are different. These two vectors are different. We can do what? We can say, oh, this vector is a good where. This vector is not a good where. So that's the basic idea. So how to do that? The words say, okay, he don't want to use just only the one. He must count the number of the engrams. So the idea I just put here is easy. Okay, I use the same notation before. I say I have the program consists of A and B API calls. Okay, but now here I show you the behavior of a program. It's A B, call A, call B, call A, call B. Then I scan from left to right with 2 grams. So AB first, all I think here, AB, all AB is here. So AB, these 2 grams contribute 1 here. And then move to right 1 position, you get a BA here, right? So BA contribute 1 here. And then shift to right 1 position, AB. So AB contribute another 1 here. So 1 and 1 is sum up, you get a 2. And BA is just only 1. So in this case, originally you probably can get a 0, 1, 1, 0. But now in this new representation, you get a 0 to 1, 0. That's different, okay? So that's the idea. So now we just follow the idea we used this before, right? We just want to get the vector from the same program before. Okay, this one is the same as I give you the example before. Okay, originally ABA, you get the vector is 1, 1, 1, 0, and ABA, you get the vector 1, 1, 1, 0. So these two vectors, they are the same. So this is no good. This is no good. But now we can use the counting of the engrams. So that because the n is equal to 2, so we have here AA, right? 1 AA, second AA, third AA, fourth AA, fifth AA, 6 AA. So we get 6. Okay, 6 AA is here. And then 1 AB, so you get 1 AB. 1 BA, you get 1 BA here. And no BE, so you got a 0 here. Okay, so now this behavior convert to this vector. You can see 6, 1, 1, 0. Quite different from before, right? Before is 1, 1, 1, 0. Okay, the second point is here. AB, okay? AB, you can see how many AB? AB, AB, 2. Okay, so you get 2 AB. How many AA? Can we see how many AA? AA 1, AA 2, AA 3, AA 4. So we get a 4 AA. Okay. Do we have the BB? No. So we get a 0. Okay. Anyway, so that means after we just follow the counting before, then this behavior is converted to the 4 to 2 0. Okay. Now you can see what's going on. Suppose this is good where, this is bad where, is learned from where, and their vector is different. This one is 6, 1, 1, 0. This one is 4, 2, 2, 0. Wow, that's good, right? Because what? I can use these 2 vectors to do identification. I say this one is good, this one is not. Because what? Because I can do the unique mapping. Okay. The left-hand side is one map to this vector here. The second program I map to another vector here, and they are different. Yeah, that's good. That's the idea. Okay. Anyway, but the words say, okay, that probably is good, but if you just want to summary standard normalization, means what? First of all, he just counted the mean value for each vector, and then he just try to normalize each item or the vector related to the mu and the sigma. Okay, so I give you an example to it could be easy to understand. So first of all, suppose I use the previous example, right? We can have this 0, 2, 1, 0. That's the vector to represent the behavior. Okay, what's up? It's okay. Okay, so now we can get the mean value. Okay, the mean value means what? We just sum up all these items. So we can have the 2, 1 is equal to 3, and then divided by 4. So we can get the mean value is equal to 0.75. Okay, and also based on these values, I can get a sigma. So you can get a 2.755. Okay. Then based on this mean value, this is the mean value, and this is the variance. And based on mean and the sigma, we can do the standard normalization. For example, suppose I want to normalize this item. I just do what? The 0 minus the mean. Okay, 0 minus 0.75, and then divide the sigma to 75. So finally, I got minus 0.2727. So that means, originally the item is 0, but now after I do some normalization, I got minus 0.2727. Okay, all other items can be doing the same things before. So I just skip this idea. Okay, anyway. So anyway, after we do such a normalization, we just convert, okay, the originally unique notation to another notation. Okay, that's the idea proposed by the authors. So then now how can we do such SVM machine? That means what, after we can convert all the programs, the behavior programs into vectors, then we can use the SVM to learn or to train the SVM. And after we finish the training, then SVM can be used to do some of the classification for the incoming program. So I don't know, as you can see here, the SVM just, is a hyperplane. So suppose we say, oh, this left-hand side is a good race, and the right-hand side is bad race. So we can use this good race and the bad race to train this SVM. To train what? We just want to get the base W and the B. W is weight. Okay, B is the bias. After we can get the base W and the B, we can do what? We can use this W and B to do classification. For example, after we finish the training, suppose there's an incoming program here, and this incoming program just put this one into the equation here. Xi is the incoming program, and then the weight is you train before. You got a train SVM before, right? And the B is also, and you just use this equation. You add the W and the incoming program, and you sum up with the bias. Suppose it's greater than 1, probably is in the right hand side. We say, oh, it's a bad way. Suppose it's greater than, is less than 1, is in the left hand side. We say, oh, it's a good way. So that's the idea of the SVM. Okay. So now suppose now you understand the idea of SVM, and then how to get the data. So the words, they just to get some of the benign. So benign is a good software. Okay. Benign means good. Okay, good software. Okay, the good way, consists of 3 and 12, and they just from somebody in the media or always through something like that. And also, the words called some ransomware is consists of 276, and this is from the WannaCry, server, Paya, crypto doctor, and so on. Okay, anyway. So totally, the words use 5 and 88 software to what? To train the system. But first of all, he must to run all this software in the Kaku sandbox to what? I told you before, right? Because you don't know if this program is a good way or bad way. You just want to get all the dynamic information. What the dynamic information we want to get? We just want to get all the API codes, right? We get all the API codes I just told you before. Okay. So the idea I just put the system for here. Okay. The goodware is consists of 312. The badware is 276. Okay. Totally, we have 588 software. And then the author say, okay, let me to run all this software in the Kaku sandbox. Okay, in the Kaku sandbox. So each point is running on the Kaku sandbox. And then after you running these softwares in the Kaku sandbox, you can convert all this behavior or this software into a vector, just as I described before, right? So probably say, okay, a good warrior 1 is converted to the vector 1, and the good warrior 2 is converted to the vector 2, and so on and so forth. Okay, anyway, left-hand side is the program behavior. Oh, no, sorry, it's an original program. And after you run in on the Kaku sandbox, then you can get all the API codes, and you convert to the 5S. That's the unique vector. So after we get all these unique vector, we want to do what? We just use this one as the input to the SVM to do what? To do the training and the testing. So that's the idea of this paper. Okay. So the words just divide, okay, the original of 588 software into two parts. One part is used for the training, and the rest of the part is used for the testing. And he just want to randomly generating all the test case in 1,000 times. So that means, you know, he just divided the 588 software for 1,000 times randomly. Okay, so that's his idea. Anyway, so after he just doing all the testing, you know, he must to get some of the metrics to say, okay, how good the SV machine he proposed, right? So now he used the idea here. Now the left-hand side is the input of the detector. The right-hand side is the output of the detector. It means, you know, suppose the input is the ransomware, and the SVM, the
Prof Horng, excuse me. The connection, Prof.
Oh, it's a ransomware. The detector is known, right? The detector is known. Okay, the detector is known. What?
Go. Yeah. It's
okay.
It's about the connection that later.
Okay.
Yeah. Okay.
Okay.
Please.
Sure. Okay. Now the ransomware is input, but the detector is known is a good way. That means what? The detector made a mistake. Okay, we say it's a false negative. So for now, we input is a good way, and the detector the SVM say, okay, it's a ransomware. That means what? It's a negative again, right? So we say it's a false positive. Okay, now we give the input is a good way, and then the SVM say, oh, it's a good way. Then we say, oh, it's a true negative because, you know, the data is good. Okay, so usually this is the evaluation matrix. Okay, anyway, we want to get an accuracy. Accuracy means what? A true positive and a true negative. You sum up these two items together. Okay, use this one as a numerator. And all the rest of 4 terms, you sum up true positive, false negative, false positive, true negative all together, and use this one as a denominator. Then this is the accuracy. Okay, that's the idea in this paper. So totally, you know, he said, okay, he can use a VM, and the accuracy is higher than 97. Okay, and the false negative is just only 1.6, something like that. And compare the paper in week is good, you know, it's about a 3% higher. Okay, anyway, that's the paper, or that's the idea in this paper. Okay, and also, you know, he just used the standardization, we say that to normalize the vector, and he found the accuracy is not so good before, and he said because, you know, he just only have the 588 software, so this could be not enough. Suppose he can get more than 1,000 or 2,000, more than 10,000, could be can have a better accuracy. So that's the he explained this idea. Okay, my questions right here. Okay, because, you know, today we just want to discuss about power processing, right? So now, as you can see, I say how many permutation or engram. Okay, I give you two API codes, and I said that I use 2 gram. So totally, you have whole permutations, right? Suppose if I give you 3 API codes ABC, and I use the 2 gram. So how many permutations you have? You can have 8, right? You can have 8 permutations. So in that case, that means the number of permutation is exponentially to the number of API calls. For example, if the API calls is equal to m, and n is equal to 2, so the number of permutation is equal to 2 power of m. Suppose m is a big value, for example, m is equal to 1,000, then how many permutation you can have? It's a 2 power of 1,000. That's very large number, That's a very large number. So in that case, you cannot just use only one computer. You must try to divide all this loading into many servers, and let all the server to run these things simultaneously. Okay, that's the reason, when we have a big problems, we have big loading, we must use the parallel processing to do it. Okay, that's the idea. I give you the question here. Okay, so because I just want to give you some of the malware analyze methodology. It can be divided into 3 major categories. We say surface analysis, stack analysis, and the dynamic analysis. The dynamic analysis just I presented before. Okay, how about the service analysis and stack analysis? The service analysis means what? Suppose you have a good way to understand, oh, this software is a virus. In probably you can use the manpower, right? To analyze, oh, this software is a virus. And this software is a good way. Suppose you can have a way, okay, you can use other way. You can use the manpower to do it, to analyze. I don't care. But now, suppose you can say, okay, 1.p. 1.p is a virus. You understand this virus, then you can find H code, okay? H is a function. You just do what? You just convert this program into a H value. That means what? P become a H value, right? So next time, if I can find another program, probably it's M, right? I just compute HM. Suppose HM is equal to HP, means what? This M program is a virus P because they are the same. Okay, so that's the idea of this hash value. Usually, for the commercial virus detector like the Shi-Jinn, they just use this idea. They use the hash function. Okay, that's the idea of the service analysis. The next one is the static analysis. Static analysis means what? They just try to analyze all the function of the program. The function or the code means what? You can, because just as I said before, right, like the API calls, you can just analyze it. Which API calls he calls, and the next time he just do something, he just analyze all the programs at 9 by 9. After he understands, oh, this is a virus. They say, okay, this is a virus. That's the idea or the static analysis. Okay, anyway. So we say that there are 3 major categories of this malware analysis. Okay, and the dynamic analysis, just as I say, we must run this program in a Kaku sandbox. Okay, so now I have finished the first paper talking. Now we go to the second one. Okay, the second one is it's general. Okay, it's a general malware detection, but we use the CNN. Okay, CNN. Okay, so CNN is very popular. Okay, but anyway, this paper I will show first year is also in 2018 in Artifial Intelligence conference on big data, and also this conference is also very good. Okay, anyway. First of all, I will just show you that what's the major operation system in a smart home. That should be the Android, right? And the second one is the iPhone. And then the third one should be like the Windows Phone or other, no more than 1%. Okay, anyway, Android operation system is the major operation system in the smart home. Okay, that's the I shall show you here. So now we just want to show you some of the security report. Okay, in the AV testing now, he shows something for us. He said, okay, in the 2005, only 17 million or malware. Okay, but now only in 2016. The malware is increased from 17 to 600 million. So it's about 20, maybe 30 times. Okay, and the problem is here. Okay, the problem is the Android malware is increased from about 3% in 2015 to 7.45 in 2016. It's about a double. Okay, and another interesting thing is he said for Android malware, almost all Android malwares are try to steal the user data from the smart home. How many? It's about 97. Okay, so that means, you know, when your smart home get the virus by the Trojan, your smart home, your data could be stolen by the attacker. Okay, and also, you know, another thing is so funny. He said almost the Android malware has dominated the market with 99.87. Almost, you know. So that means, you know, probably if you want to buy a smart home, right, you must try to buy the iPhone instead of use the Android home. Okay, so Android home is not safety. Okay, anyway, okay. Okay, and I also give you some of the data they just collected from the US, UK, and France. Almost all these malware they just created from all these developed countries, you know. So that's I show you here. Okay, anyway, one more report is also quite for us in the mobile security report. He said, you know, Android malware is in 2012 is about 1 million, but you know, out of 2 years later, it's increased 3 times, and then in 2015, another 3 times is now is about 9 million. Okay, and in 2016, it's increased to 17 million. That means what? That means, you know, the malware is generated rapidly. Okay, day by day, you know, so that's quite seriously. Okay, anyway, so we must very care about the malware. Okay, so why the people or the attacker, they like to use the malware to attack the Android system? Look here, you know, in the Android operating system, they have the Android picture. We name as APK. Like the P home method we use in the Windows system, right? APK. And APK, they consider so many fields, but the important thing is the classes.txt. Classes.txt is the executable file. They store all the execution file in this field. Okay, so this field is very important. That means that if you want to do some computation, the program is stored here. Okay, that's the classes.txt. So I give you a general idea of the APK. That means, you know, when you write the Java files, and then you must go to the Java compiler, and out of the Java compiler you get a class files, and then you can use the text to convert the class file to the text file. Okay, I say this text file is the executable. The file is here. Okay, and then you can use the APK ability to generate APK package. Okay, and this one is just we say this APB we can use in smart home. Okay, so now so usually the words say, sometimes the people use the stack analysis to say, oh, this one is a whale or it's a bit whale, just as I say in the previous before, right? But somebody used the dynamic analysis just in this paper. Okay, so now I will say that I just show you something about how to define a variable in a program. Usually, for a good way, when they define a name or variable, they will use some of the meaningful variable. For example, like this one, he say will say a parameter in the bitmap is a variable or something, and a parameter LCD from something is another variable, and this variable is meaningful. But for the we say it's a malware, they don't use the uniform notation. They just give you the name in a randomly. Okay, that's the idea. They are different. Okay, and also because for the malware, they try to fool the detector. They will include some variable. For example, the JJ, they include to these things. What? They just want to fool the detector. Say, oh, now because now a JJ is in this code, so the detector cannot identify. Oh, this is a good way or this is a bad way. Because what? He can understand this code is equal to JJ. Okay. So anyway, that's the idea. Probably we give you some of the things about the bad way and the good way. And now I will give you some of the machine learning based for the malware detection. Why we can use the machine learning? Not because we can use some of the machine learning technique, like I explained before, to learn the pattern and then build the model, and then use this model to do the training. And after we finish training, we can use this model to do detection. So that's the idea of the machine learning. So and usually, that's FSM is very popular before. So currently still there are so many people they use FSM to do training and testing. And then also somebody use the random forest. Okay, random forest is also another way to do it. But today I think I give you the SB. I think that's enough. Okay, so and I give you some of the papers. They just use the ways for the machine learning before. That I show here in the reference statement, and I also give you some other things. But there's something I want to show you is that because their paper the big point is that they use small data sets. Okay. Their data set is so small, probably just only just 100 or 200 data set data items. But in this paper, the data set is more than 10,000 or even higher than 10,000. Okay, I will show you in the data. Okay, and also another way is that we currently we say the deep learning is the major machine learning technique that we can use to do the detection about malware or ransomware or virus, or you can use this one to do other things. And deep learning, is kind of machine learning technique. And I would say that deep learning is very similar to the neural network before. Suppose you understand neural network, deep learning is actually neural net, and then that means in the deep learning you can have so many layers, and one layer connect to another layer is through some of the links, and with some of the weighted to connect from one layer to another layer, and because we want to data the deep learning to do some of the training, so usually we must use some of the back propagation. To do what? We want to use this one to adjust the weight and the bias or the system. So how to do that? When you can have one input to the deep learning neural network, and out you get the output. you just compare this output. The output could be the predicted output, and with the ground truth output, you get a difference. So if you can get a difference, that means what? The system is still not stable. So you can use this difference to get the summary, the data information back to the previous layer to do some of the adjusting about the weight and the bias. So that's the idea of the deep learning. Okay. So and currently I would say that the most important deep learning is CNN. Okay, that means the convolutional neural networks, and also based on the CNN, there are some of the popular backbone like the AlexNet, VGNet, GoogNet, Inception VSRNet, something like this. You know, this background network is very, very popular. Okay, I just show you in this reference. Okay. Anyway, I just show you an example. I said AlexNet. AlexNet is very famous, you know. For the first 5 years, the first 5 days is this convolution and followed by the pulling layer. So for the first 5 years, the AlexNet is just used to learning the features. Then the feature means what? The left-hand side is the input, okay? Left-hand side is the input. And then the input going to the AlexNet, and all the features will be learned by the AlexNet. After the AlexNet finishes the learning, right? He will go to the next 3 days to do what? To do classification. For example, you know, here, you know, there's a cattle, there's a horse, there's a monkey, there's a bird. All these horse, monkey, bird go into this net, and this information, this feature will be learned by this AlexNet. And then based on these features, the last 3 days can classify, oh, is it a bird, or is it a horse, or is it an animal, something like that. So this is the last 3 days, the function of these 3 days, just do the classification. Okay, that's the idea of the AlexNet. Okay. But you know, somebody just used okay. Suppose we want to use the deep learning approach to do the malware detection. How to do it? Okay, in this paper, he said, okay, I just want to get some of the information first. Like, you know, he just want to get the B format and the string 2D histogram features in the PE metadata, blah, blah, blah. And then out of preprocessing, this data is fed into a DNA. DNA is a deep neural network. For what? They want to use the DNA to do the training and do the testing. And in the next paper is 19, right? This one is also, oh, I want to get some of the previous features like the sensitive API and the dynamic API calls like the load, the resend and service blah, something like that. And all these pre-processing features, yeah, then fit into the DBN. DBN is another deep network. But anyway, I would say that in these 2 papers, you know, first of all, the workers just use another way to get some features first, and then just use the features as input to the next deep neural network to do the training and testing. That's the idea of these 2 papers. Okay. Anyway, but here I want to emphasize in this paper is that in these workers, they say, okay, I don't use the ways they proposed before. They just do what? They just convert all the program into images. Wow, that's interesting, you know. Convert the program into images. Remember, in my first paper, I say convert the program behavior into a vector. But now, this idea is to convert the program into an image. It's an image, not a vector, or it's an image, okay? So that's the idea in this paper, okay? So now, because of that, you know, he just want to criticize, you know, why he used the image instead of engram. Because I said, I give you the question before, right? Suppose you use engram, and the size or the API call is equal to m, that could be the number of permutation is equal to 2 powers m. So that's a very huge, okay? So the author say, okay, I think English is no good. Okay, so he said, okay, we want to use the CNN. Okay, so that's the idea in this paper. Okay, how to do it? He says, okay, I don't want to use somebody name before. He said, in this paper, he uses CNN, but how to use the CNN? He said, okay, he first of all, he convert all the OPI code in one hot encoding. Okay, let me show you what's going on. Suppose, a program, okay, a program, that's now, this is not the API code. This is the older OP code. When you just finish the compiling, right? You can get the object code. You can get the node, add, store, some store, and add something like that, right? So this is the program, okay? So in the OP code is sequence is like this way, okay? But we don't execute this program. We just see, oh, this is the program. Then what? In 24 this paper, he just converted this optical sequence into a one hot vector. How can we define the one hot vector? The one hot vector means here, okay? We say, okay, for example, the index one means the node. Suppose there's node appear in the optical sequence, then here will be put one, okay? And the second item is 8. Suppose they are 8 in the optical sequence, then he will put one here or power in something like this way. So, for example, suppose if a program is an optical sequence like this way, power 8, and then store power, then we convert this optical sequence to this one hot vector like this way. Okay, you scan here, power any node here? No. And it here is 1, 8. And it's still here is Baba and other. So this optical sequence is converted to 0, 1, 1, 0, 1 hot vector. Okay. Then instead of input this optical sequence into the CNN, we just input this one hot vector to the CNN. Okay. That means, this CNN, the input is from the one hot vector, and then use this one hot vector to do the training, and then use the other. We finish the training, we can use this one to do the testing. So that's the idea or this reference 24. But the author say, no, I don't want to use the one hot vector, because the one hot vector means what? This vector is very big, as you can see. The one hot vector here, the length of this one hot vector is very big. Okay, so the author said, I don't want to use this one. What he want to use is convert the program into image. Okay, convert the program into image. Okay, how do we do it? It's easy. Okay, now I give you a David bytecode here. I say 71106101 blah 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 blah. Okay, this bytecode is used to install other APK, but we don't care how they know this bytecode. We don't care. What we want to care is how can we convert this bytecode into image. That's the idea. Okay, let me show you what's going on. So first of all, in this algorithm, okay, the idea proposed by the work to say, okay, I first convert all the classes of the text into RGB color image, and then based on this image, we can use the DNA to do the training and the testing. Okay, that's the idea here. So how to do it? It's easy. So first of all, the class.text is the, I say the execution file of any Android app, right? I told you before. And then this bytecode is converted to a color image. Okay, we convert a color image from this classes.text. Okay, this is the executable file, right? And then we have this image, and this image is used as an input to the backbone CNN. The backbone, you can use the AresNet, you can use the GoogleNet, you can use the InceptionNet, anywhere, any day, all are usable. Okay, then you can use this one to do training and the testing. Okay, so then here, we must to tell you that the how can the worker to get all this malware in the midnight and the Trojan like he, he correlated from the because he just cooperation with the Leopard Mobile Inc. So and they create the midnight Trojan risk to popular and all these things, and just have this software as the training data and the testing data. Okay, now I show you how can we convert this software to the image. Okay, for example, now we have the 64, 65, 78, right? This is the bytecode. Just we can say here before, right? Like this way. We say like this one. Okay, this is the bytecode 7110, right? 6E01. That's the bytecode. And then we just say, okay, we put the two bytecode to this to hold the R color. So 64 is becoming 100. It's a hexadecimal code, okay? So 6 multiply 16, you get 96. And plus 4, you get 100. And then the next 2 bytecode is 65. It's become green, the 101. And then the next is the blue, 78 convert to 120. So these 3 bytecodes, 64, 65, 78, is converted to the RGB. Okay, RGB means pixel 3 values. So 64, 65, 78 converted to this color. It could be a little gray, right? It could be a little gray. Okay, so that means you have 3 codes, and the 3 codes can be converted into 1 pixel. Okay, 3 codes, 3 bytes converted to 1 pixel. Okay, so the next 3 codes, right? Probably 0, 8, 30, 33 convert to another pixels here. Okay, anyway, so that means for each 3 bytecodes convert to a pixel, then you can convert all the bytecode to an image. Okay, look here. Here you can see, oh, this is an image. This image is followed from the classes.txt. Okay, let me show you again here. Classes.txt is your executable file. It's a bytecode. Then we just use a 3 bytecode to convert it to a 1 pixel. Okay, so then you can convert the executable file into an image. Or like this way, image, another one. Okay, each corresponding to a program. Program 1, program 2, program 3, program 4. Okay, that's the idea here. Okay, and also, somebody the image for the malicious enjoy app look like this way. Okay, so the next thing is, the words just want to say, okay, somebody we say that the male family, they look similar in the image. Okay, for example, this one, this one is a bus enjoyed Docker. Okay, this malware convert to image like this way. You can see the image is this way. And another category is enjoy Trojan.sdocker. You convert to an image. What is image? The left-hand side and right-hand side look quite similar, right? Probably only here, okay? The color is a little different, okay? This one is the green. This one is a little red, right? But anyway, you can see, because it is a family of malware, they are almost do the same thing, okay? So they convert to the image. They look so similar, okay? They look so similar, okay? So now, you may get one question. How can we to measure how similar these 2 images, okay? So you must have a metric to do some of the evaluation, right? So usually, they just use some way to do the metric. So I just will show you, okay. Okay, anyway, I will show you later, okay. Let me see, probably, or no. Okay, Before I give you the how can they do such a measure, okay, I will tell you some of the things about the Google backbone. Okay, the Google backbone, you know, they use the insertion like in the defense side. Originally, they proposed this way, but then they used another ways. Originally, you know, they use the 1-1 conversion and 3-by-3 conversion, 5-by-5 conversion, and blah blah, and something like this way. But anyway, they just want to use the different conversion to get the different features, and they just want to get a different skills. Okay. Anyway, after they finish all the convolutions, they can concatenate different feature image all together. Well, that's the idea proposed by Google. Okay. But you know, finally, the Google think, oh, it's so many computations. So Google just use another way. They just use 1-1 convolutions before the 3-3 convolution here. Okay. So you can see here, before 3-3 convolution, he put a 1-1 convolution. And then before the 5-by convolution, he used another 1-1 convolution to do what? They just want to reduce the normal channels. Originally, the channel is 192, right? After they use 1-1 convolution, the channel is reduced to 96. So 192 is reduced to 96. So you can see for the next 3-by-3, the input is 28/20 96. The channel is reduced 96. Okay, but the previously is 128. It's 128. Oh, sorry, it's 192. So as you can see, based on such reduction using the 1-1 convolution, they can save about a 30% of computation load. I didn't give you all the detail, okay, but I will tell you. I just tell you that for the inception V3, they can reduce so much computation load. Okay. So, and the idea of this paper is that they name is R2D2, right? How to do such a checking about the apps. Or first of all, you know, suppose now you have an iPhone, or you no iPhone, it's Android phone, right? Like the Sony or the other some smartphone, but the operation is in click one app.
Hello, Prof. Excuse me, Prof. Horng. Your connection, Prof. Hello, Prof. Horng.
The smartphone with skin. Oh, it's okay.
Yeah,
it's okay.
Yeah, it's okay. Yeah, come on, Prof. Please. Prof. Hello, Prof. Horng.
Can you hear?
Yes. Yeah, it's
okay.
clear. Yeah,
it's okay.
Please. It's okay, Prof. Oh,
He's gone, Mr. Agus.
He's gone. He's gone.
Yeah.
Okay, it's about the connection. Sorry, ladies and gentlemen. We are waiting him to join again.
Actually, he's already here. Prof.
Okay.
Yeah. Okay, we are waiting for the connection from the Taiwan to Indonesia, perhaps. Yeah. Okay.
All right. Hello, Prof. Oh, okay. Prof, your connection. It's about your connection. Prof, I'm so sorry. Your time is about 10 minutes more. Okay. You are still mute, Prof. You are still mute. Please unmute. Prof, you are still mute. Okay. He's gone. Mr. Jimmy?
No. Wait a second. Okay.
Okay.
From yeah, that's still with us. He's still with us. Prof.
Okay.
Shi-Jinn still with us.
Okay.
Yeah, still some problem. The connection, maybe from the audio. Yeah.
Yes. Prof.
Okay.
Horng, are you there? Prof. Horng, do you hear my voice? Okay. Prof. Horng?
Still mute
Still mute.
from yeah, the
Still-
audio from Mr. Hong still mute, Mr.
You are still mute, Prof. Please unmute. We cannot hear your voice, Prof. It's about the you checklist the unmute.
Okay. Okay.
Okay.
Can you hear me?
Yes, Prof. Your
Okay,
time
sorry.
is about 10 minutes. Okay.
Oh,
Thank
sure.
you. Yeah,
Okay,
thank you,
sure.
Prof.
10 minutes is enough. Okay.
Thank you,
you.
Prof.
Sorry. Okay. Okay, so now we go back to here, relatively, first of all, the smartphone just scan these apps. Suppose it's recognizable. Then he was, now we can use this app. Suppose it's not recognized. He will convert this app to the color image and then upload this color image to the backbone. Okay. And the backbone can do some of the checking about this color image to say, oh, is this a virus or this malware or this goodware? And then report this message to the users. So that's the idea of the R2D2. Okay. So, because he just want to say that he want to run this program in Ubuntu 64-bit. The hardware is here. And also, he just to collect some data from the Predator Mobile Inc. It's about 72 GB. And also, they collected data from January 2017 to August 2017, about 8 months, to get about so million of benign and malicious enjoy. So their data set is very, very big. Okay, so in they just use the three network, we say AddressNet, GoogleNet, and Essentially3 to do all the experiments. And they use different kind of optimization like SCD, NAG, ADA Dirt, and ADA Gram, and something like that. They finally say, okay, the Essentially3 is the best one. And so they finally just use the Essentially3 as the backbone to do some of the testing. Okay, so I just use here in the Essentially3, you can see the accuracy is quite high. Okay, compared to the Ethernet, is a little low. Okay, and in this case, he said, okay, now I use the Essentially3 and use different kind of optimization, straight like ADA Delta and ADA Green. And they say, okay, HD could be the better. Okay, so finally, the worst, okay, he only used the Essentially3 and with the SGD, and he just showed the results here. Okay, that's the idea in this paper.
Prof.
Okay,
Horng,
anyway, okay.
Prof. Horng, I'm sorry, your presentation is not here.
Not here?
Yeah. Would you like to represent your presentation once again?
Can you hear now?
No, not right now. Not right now.
Okay,
Your presentation is not here. It's not
so
show. Yeah.
Oh,
Would you like
so
to?
you mean the PDF file? You can see
okay.
the PDF file.
Sorry.
You can see my PDF file.
Yeah, I cannot see your presentation, Prof.
Okay, let me show. Let me see
Yes.
what's going on.
Thank you, Prof.
I must to share, right? To share.
Yeah. You have to share first. Yes.
Okay. So can you see now?
Yes. Yes, it's
Okay.
clear, Prof. Yes.
Oh, sure.
Thank you, Prof.
Okay.
It's okay, Prof.
Okay, so. So can you see the screen now?
Yes, Prof. It's clear.
Okay. Anyway, I see that because originally they just want to use a different kind of backbone, like the AddressNet and GoogleNet and the Essentially3 net to do the experiments, and they use the kind of optimization like SCG, energy, and eta data. And then finally, they think they just do the experiment and they just find out inception basically can get the base accuracy. Okay. So here, I just show you the experiments. You can see inception basically is get the base accuracy compared to the one ADSNet here. ADSNet is a little inferior to the word inception basically. So, and then finally, just compare the inception with different kind of optimization like the eta green and the eta data. And they find with the SD is the best one. Okay, that's the idea shown in here. Okay, so that's the final result shown in figure 19. Okay, so and also, the words just try to evaluate how good the system in the real environment. So they use the two PPFP. Just as I described before, right? They have TP, FN, FP, TM. And the equation is put here. You can have the accuracy rate by this equation, and PI by this equation, and F1 score by this equation. Okay, anyway, so the equation they use here. But I just want to show you the final result here is that they say, okay, the precision is higher than accuracy after the threshold value is reached to 0.6, but after the threshold is over 0.7, then the required F1 score start to drop, and also means that the accuracy is not good as before. Okay, let me show you what's going on. Okay, here you can see, as you can see, when the threshold value is 0.6, you can see the precision. Okay, the precision is a little higher, and then the threshold up to 0.65 is higher than the accuracy. Okay, that's the precision. And then goes, but you can see the F1 score and the recall is drop. It's drop. Okay. Okay. The precision is a little higher again, but the F1 score in the recall is drop. So that means the threshold value is, you can use this one to say, okay, this is this malware or this is goodware. The threshold, the purpose of this is just doing such a thing. But which threshold is the best one? You must do the experiments to analyze where is the best threshold value. Okay, that's the idea in this paper. Okay, anyway. So I think I want to go into details about this paper. So I show you the conclusion here. Okay. So I said I give you 3 statements to the conclusion. It's very simple. I say, do not click any suspicious connections. When you get some other connection from somebody, okay, or from email, don't click the suspicious connection. It's quite dangerous. Okay. And also, update the virus detectors all the time. When your computer, okay, you must try to update your virus or always the time. Sometimes if you don't update your computers, you will be infected by some virus or some of the virus. Okay. And then the last thing is, the device is actually as a corporation. It's very important. Okay. So, and finally, I will give you some of the advertisement here. Because I am come from National Taiwan University of Science and Technology. And I will say that my university is ranked top 5 in Taiwan. The number 1 university is the National Taiwan University. Okay, and then go to Tsinghua, Chenggong, Jiaotong, then goes to my university. Okay, anyway, and the QS ranking, Taiwan University is 69. My university is about 251. Okay, and my university is located in Taipei. Taiwan University is also located in Taipei. We are neighbors, just only cross one street, okay, only one street. So suppose if you have a chance to study in Taiwan, you probably can come to my university, okay. Tsinghua and Jiaotong, they are located in the Hsinchu, okay. It's about 8 kilometers from Taipei. And Chenggong University is located in the south. That could be 250 kilometers from Taipei. Okay, so try to come to my university. and thank you for your listening. Okay, finish my talk. Any questions?
Okay, thank you very much, Professor Horng. That was very impressive, your explanation.
Yeah.
Multimedia. Is there any bumper? No? No? Just go on with the Q&A. Okay. Okay, thank you very much, Professor Horng. It was amazing, your description. Okay, we go on with the question and answer session, yeah, Prof? Okay, ladies and gentlemen, feel free and provide as many as possible questions, or you may want to talk directly to the professor, or you want to chat in the chat room, please.
Yeah.
Okay, Prof, there is a question from Bapak Sabarudin Siagian, and he is going to translate, Prof. Okay, here is the question, Prof. By the approach of the findings of support factor machine and convolutional neural network, is there any impact related to the smartphone's Android capabilities in the next future?
Okay, you mean the deep learning? Can we use the deep learning in the smartphone?
In smartphone, yes, Prof.
Okay,
yes.
Okay. I will tell you something. You know, suppose if you try to use the AlexNet or the GoogleNet or Google insertion in the smartphone, that could be impossible. Because you know the smartphone, the computation power is not enough to do some of the computation like to do some of the computation in the AlexNet. But anyway, some of the deep neural network like the mobile net, the mobile net can be computed in a smartphone. Okay, even we just use some of the other ways we can just to reduce some of the computation in other nets and then install this neural net in the smartphone. You know, like in my day, we just use the mobile net, and the mobile net we can just run in my iPhone no problems, because my iPhone is the 10th generation. Now I think the mobile is going to the 13th generation. It's more powerful, and also we also deploy some of the PC mobile home. HTC is very popular in Taiwan. Okay, we also running some of the deep learning, like I said, mobile net in the Android system in the HTC. It's okay. It's done so smoothly, and because we want to get some of the image, and for the iPhone we can get about 1 second. It's about 6, and for the HTC it's about 30 frames to get the image. So no problem. So I think now you can develop so many applications based on the deep learning to the smartphone. I think that is now that's not a major problem. Okay, yeah. So that's my answer.
Okay, thank you, Prof. Ya,
Yeah.
Bapak Sabarudin. Jadi penjelasan dari Prof Horng bahwa penggunaan smartphone itu lebih untuk anak-anak millennials gitu ya. Sedangkan yang zaman sekarang itu menggunakan mobile agent di sana, dan ada kelebihan, ada kekurangan terkait dengan smartphone dan mobile. Kalau smartphone itu bisa menggambarkan dalam satu frame dengan 20-30 images, sedangkan untuk mobile itu tidak bisa gitu. Jadi ada lebih, ada kurang gitu. Gimana Bapak Sabarudin? Is there any, Bapak mau bicara langsung dengan Prof Horng? Bagaimana? Bapak Sabarudin ada? Halo? Pak Sabarudin? Ada? No. Okay, we go on with Prof. We go on with the next question, ya, Prof.
Yeah.
Okay, Prof. Horng, may I read your questions for you? How many images do you get from an Android application? Can we use fully connected network instead of convolutional neural network with the same good performance? This is question from Agus Subekti, Universitas Nusa Mandiri, Prof. Please,
Okay.
Prof.
Okay. I think suppose if you use the fully conditioned layers to get so many fully conditioned layers to do the such classification, then your computer should be so powerful. Okay. So that's why, you know, Hinton, you know, they just invert the CNN because what? They think, you know, they want to get the features from the images. So they want to learn the image, the hidden feature. They use the convolution. And the convolution, you know, just about, you know, just as I mentioned before, we can use the filter size 3x3 or 5x5. We don't need to use the full connected layer because what? That you need so many computations. So in that case, suppose if you want to use the fully connected layers, all are connected by the fully connected in the smart home, I think you probably can run your program. But anyway, suppose you use, as I say, use the CNN, okay? CNN, you know, they just only to do some of the local computation, okay? They use the local computation. And then you can save so much time. And you probably say, okay, suppose if we just use the local computation, how can we get the hidden information or hidden features? Because what? Because, you know, we can just extend the number of layers. There you say already probably only 3 layers. Now we can use the 100 layer, 200 layer, or even 1,000 layers. Okay, so from layer by layer, you know, the layer by layer, the reception fields will be increased. So that means, you know, originally, if you want to use the fully conditioned to do the summary classification, now we can use so many layers concatenated together. And then we can use these so small filters to do the computation, and you can get all the powerful features to do the classification. So I mean, do not use the all the fully conditioned layer to do such a classification. You must use some of the convolution layers before, and then follow just only 2 or 3 fully conditioned layers. That's enough. Okay, that's my recommendation. Okay.
Yes. Okay. Thank you. That is the recommendation from Prof. Horng. Mr. Agus Subekti. What do you think? Is it Mr. Agus? Is there any comment from you, sir? Mr. Agus? No. Okay. All right, we go on with the next questions, Prof. From Ibu Diah Puspitasari, our Vice Rector. Our Vice Rector, the one that you say that her face is just similar with your student. Okay, this is the question, Prof. What are your considerations to choose support? What is this? SVM support
Vector machine.
So, Ibu, do you want to ask directly to Prof. Horng?
Okay.
Okay, please.
Thank you.
You're welcome.
Yes. Good afternoon, Prof. Horng.
Yeah.
Yeah.
So what's your question?
Yes.
Yeah.
Thank you, Prof. What are your considerations to choose supervector machine and convolutional network approach at your research? Thank you, Prof.
Yeah. So can you what's your question? I cannot understand, sorry. So what's your questions about the SVM?
Yes. Why you choose SVM and CNN at
Okay,
your research?
okay, easy. Okay, sorry. Because today, the topic is about artificial intelligence. So I just choose to very popular technique. We can use this technique to the summer security. The SVM is very simple and it can run so quickly. Okay, so SVM is that's why I choose SVM first, and then we go to the CNN. Okay, now SVM is very popular before. In SVM is a classify, is a binary classifier. So in as you know, we want to detect is this ransomware or is a goodware. That's a binary classification. Okay, so SVM is very suitable for do such a detection. Okay, we are not doing any classification like is a horse, is a car, is a people, is a motorcycle, is a car. You know, that's the classification is more than 2, right? But for the classification for the malware or the goodware, that's only 2. And SVM is very suitable for the binary classification. So that's why SVM can be used for the we say the virus detection or the malware detection. So that's why I choose SVM as the first topic order today. Okay. So in the next one, you probably ask me why I choose a CNN. Because what? CNN now is very popular, and then CNN can do many things in the image processing. Okay, you can use the image to be an input to the CNN. For example, you can use the Google FaceNet to do such a face recognition. Suppose if you have iPhone or you have smartphone, then everybody, when you want to open your smartphone, you must use your face, right? But as you know, the Google FaceNet is very well trained. You can download the Google FaceNet, this package from the Google website, and then to your computer, and then you can use your webcam to do some of the face recognition. Okay, so why I choose CNN? Because CNN is very popular, and the CNN, as you know, originally they are very useful for the image processing, like the face recognition or the image classification. But you probably will ask me why you choose a CNN to do the malware detection. Now, okay, I give you the answer is here. Okay, the malware is not only just the binary classification. It can include Trojan. You can have a virus. You can have some other different kind of virus. We can give different name or the virus classification. So that's why I choose CNN to use as the classification. Not because SVM is a binary classification, but for the malware, you have different kind of malwares, right? So each malware can be classified into one category. So suppose if you have 10 different malwares, then you must use the CNN with 10 outputs. So that's why I choose CNN for the malware detection. Okay, can did I answer your questions?
Yes, thank you. Quite clear, Prof.
Okay.
Thank you.
Okay.
Thank you, Budia. Thank you, Prof. I think this is the last session for question and answer session. Ladies and gentlemen, thank you very much. And Prof. Horng, would you like to stay there? Because there is something on occasion regarding to you, but would you like to stay there? And I would like to read the conclusion, ladies and gentlemen. Here is the conclusion as I got the information from Prof. Horng's slide. Do not click any suspicious connections. Okay. And then update the virus detectors all the time. So ladies and gentlemen, do not forget to update the virus detectors for you to save your data in your laptop, in PC, or in handphone. And the last is division as well as cooperation. Okay, thank you very much, Prof. Horng. And this is the end of our discussion. I hope this webinar will be very beneficial to you. I do apologize for the inconveniences. Thank you for joining us and see you on our next webinar. Wassalamualaikum warahmatullahi wabarakatuh. Have a good day. I'll give it back to you, Mr. Jimmy. Thank you.
Thank you, Mr. Agus. So, ladies and gentlemen, and all participants to the next agenda, conferral of the placard symbolically from Rector to the Honorable Speaker, Professor Shi-Jinn Horng, to Bapak Dr. Muhammad Waidi, MM, MCom, MPD. Please, time is yours. Okay, Bapak Rektor. Yeah. Prof, as you can see on the slide, okay, this is our officially placard to symbolically to give to you, to Professor Shi-Jinn Horng as our keynote speaker in this occasion, webinar Studium Generale. Hopefully, it will be acceptable for Prof. Shi-Jinn Horng today. Thank you.
Okay.
Okay, ladies and gentlemen, may we invite all the participants, include the keynote speaker, Mr. Professor Dr. Shi-Jinn Horng, to activate all the camera for the documentation. Okay, so all right, we have a 9 slide in the today. All right, the committee is ready. On my mark, okay, give me your best smile. Okay, Prof. Shi-Jinn Horng, we need your smile in this occasion. Okay, on my mark, on the first slide, 3, 2, cheers. Okay, the second slide. Okay, ready? On my mark, 3, 2, 1, smile. Okay, and the last slide, and this is informal style. Prof, could you show me to, what is it, like a freestyle 2 times for every participant here? Okay, all right, okay, the committee, please. Hold on, okay, on my mark, 3, 2, 1. Okay. All right, okay. All right, ladies and gentlemen, the questionnaire link is sent into the chat box and all participants will get its certificate. Please, time is yours. Okay, for the questionnaire link in the slide, yeah. Ladies and gentlemen, now we have come to the end of the event. A great appreciation to all of you for having the pleasure of attending the entire event, especially to Professor Shi-Jinn Horng to having spent your time and join us on the webinar Studium Generale Universitas Bsi Bersama Informatika Thank you very much for attending, Prof. I hope you always great health and could be join us on the next webinar. Thank you very much, Prof. And should there be inconvenience matter within the presentation, please allow us humbly apologize. We wish you a very pleasant day, a great day. Thank you very much. See you another webinar. Stay safe and salam sehat. Goodbye, everybody.
Bye-bye.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Bye.
Okay.
Stay healthy, Prof.
Kuliah BSI Aja.
Thank you, Prof. Shi-Jinn Horng,
Thank you so much,
Didi,
Professor.